Welcome. This is Registered by RK17CS183 and today I'll be demonstrating our lab experiment number 10 graph traversals, and let's directly jump into our first program. So as you can see here, I've created few variables name as cost, IJKN, stack, top, P, Q and front rear. So front rear is for the Q. So we'll see how we have used all this variable inside the program. So at starting I've created inside main, I've done everything inside main only, and I've asked the user to enter the number of vertices. So each graph have the number of vertices and number of edges. So edges are going to define how vertices are connected to each other. And as you can see here, I've used a small for loop to give the input, and each input will generate inside 2D array a cost. So suppose if 1 is related to 2, we have to type 1 2 and the cost will be set to 1 to that particular array, like particular blocks in 2D array. So this thing I'm going to use to define the relations cost, and we'll see how it's going to work later. And all the visited and visits are going to be initialized as 0, because if it's visited, we'll set it to 1, and that is going to help us to signify that we have already been to this node or not. And inside, then we have created a menu driven system, and we are giving a scene choice. If it's BFS traversal, we want breadth first traversal or depth first traversal. And inside case, let's see, our first traversal is BFS traversal, and we are going to put the first node, the one we going to start with. So this is going here, we're going to enter the initial vertex, and as you know, graph traversal can any node can be the starting node, and we have put that particular node as visited first because now we already visited that node, and we are using k equal to 1 while k is less than n. So n is the size of our all the vertices that we are passing. So suppose we are passing number of vertices as 6, so n is the size obviously, and k will keep on increasing because we want to visit each and every node, right? And inside a for loop, we are going to check here according to the cost. So suppose let's take example of we are starting from 1 and we have a relation from 1 2 and 1 3, and we don't have any relation as 1 1. So it's, see, if it's saying cost of 1 1 is not equal to 0, means obviously, because here we have given whichever the cost is there, it's set as 1, or else everything else is generated to already 0, right? So this is going to be 0 and it's going to come out of loop. But if it's 1 2, then it's generated as 1, that is not equal to 0, and it's visited is also here set as 0 0. So basically it's going to enter into this loop, and it's going to put visit j, means like it's currently visiting that particular node, and then we are going to put that value inside our queue. So basically how queue works for us is we keep on inserting in queue, and then at the end we take out the values in the queue from the front. So we keep on adding the values in the rear part, and in the front part we are going to keep on displaying the values. So that's how we get our BFS. Let's see the DFS logic. It's quite similar other than the queue logic, because here in DFS we display the node value and we go to the next value unless it have the next depth value. So BFS actually follows the a level order traversal, and DFS follows the pre-order traversal in our normal traversal logics. And as you can see here, I've used almost the same logic. Instead of queue, I've used here stack, because as it enters to a new node, right or child, doesn't matter, it's going to put it in the stack and it's going to visit all its children, and until and unless it's all its below children are visited, it's not going to pop that thing out of the stack. And once it is visited all its children, it goes back to that particular node, it will then pop out that stack, and then we will print this the value of the stack, and we're going to reduce top minus 1. We keep on reducing and we keep on popping from the top, and as you can see here, we will get our DFS traversal. So let's run this program and check. So it's asking me to enter the number of vertices. Let's enter number of edges. So let's add 1 2. Okay, sorry, it asked me number of edges, I entered 12. So let's run this program again. It says number of edges, let it be 5 because we want one less. 1 2 2 2 2 3 3 2 4 and 4 2 5, and let it be 3 2 5. Now it's asking me if I want BFS or DFS. Let it be 1. So as you can see here, it is displaying me 1 2 3 4 5. So we got what we wanted. So as you can see here, the relation is from 1 to 2 to 3, 3 to 4, and 4 to 5. So we are getting it in sequential manner because BFS is going to display the graph level orderly. Let's see DFS. So as you can see here, we are getting all DFS as well as in sequential order. So we have successfully completed our experiment number 10, graph traversals. Thank you so much for watching.